Okay, in this video we're going to cover the 6.2, the law of sine. Okay, we are going to talk about the law of sine, and there's going to be three cases in which we're going to use it when we have an angle side angle or a side angle angle, and then we can also use it for a side side angle. Okay, the law of cosine will be for the side 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 or the side angle side. Okay, so I'm going to just divide it right here. Okay. When we're using the law of sine, you can use the form like this or like this. Typically, I use them like this. I always have. And the law of sine basically is a complete ratio is equivalent to the other ratios in a triangle. Number 1 says solve the triangle, round the lengths of the sides, and measures to 1 decimal place. Here we're given 2 angles and 1 side. It's easiest to first find the missing angle. So let's find angle C. Angle C would be equal to 180 degrees minus 105 minus the 48 degrees. Okay? When you put this in the calculator, you will get 27 degrees. So that would be angle C. Now that we have one complete ratio, angle B with little b, we can find the side A or the side C. Okay? Start with the complete ratio first. I'm going to use sine of 105 degrees over 27 is equal to, and I'm going to solve it for A. So I'm going to say sine of 48 degrees over little a. Here I'm going to be using the bat and ball. The two diagonal that are completed out will be my bat, and this is going to be my ball. Okay, so I can say A is equal to 27 sine of 48 degrees, all divided by sine of 105. Okay. Make sure your calculator is in degree mode, and then we're going to go ahead and plug it in. 27 sine 48 divided by sine 105. Okay. You get approximately 20.8. Part C, we're going to use the same ratio that we had before. You never want to use the side that was rounded or an approximation. So we're going to use the values that we were given. I'm going to start with sine 105 over 27. And I'm going to set that equal to sine of angle C, which is the one we found, 27 degrees, over little c. Okay? Bat and ball, C will equal to 27 sine 27 degrees over sine of 105. Okay. All I'm going to do here is just go up, since the calculations are already there, and I'm going to change this one to 27. Okay. This is going to be approximately 12.7. Okay. Number 2. Number 2 says solve the triangle. And here you're given your 3 pieces of information. Okay, 2 angles. Let's find the third angle. C will be equal to 180 degrees minus 32 degrees minus 78 degrees. Okay, use your calculator. You'll get that equal to 70 degrees. Now that I have one complete ratio, sine of C divided by 57, we can use that to find one of the other 2 sides. Okay. Sine 70 degrees divided by 57 is equal to sine of 78 divided by, this is big B, I'm going to use little b here. Now I can do bat and ball. B is equal to 57 sine 78 degrees divided by sine of 70 degrees. Plug that into the calculator. 57 sine 78 divided by sine of 70. And I'm going to get approximately 59.3. Now we're just missing a. I'm going to use the same ratio. Sine of 70 over 57 is equal to sine of 32 degrees over little a. So a will equal to, bat and ball, 57 sine of 32, all divided by sine of 70. Okay, I'm going to go ahead and plug this in, and the only thing that changes from these two is my degrees. So I'm going to go up and then change my degrees to 32. And A would be approximately 32.1. So when we're solving a triangle using the law of sine, given side-side angle, what we're trying to do is determine if we're given a side, another side, and an angle, can we form a triangle? And there's going to be a couple of different outcomes. The first outcome is we cannot create any triangle. Another solution is we can create one triangle, but it would be a right triangle. So this A, and this B is what's given. We could also create another triangle, but it would be an oblique triangle. Okay, so here this is what the triangle would look like. Or we can possibly create two triangles. All right, now this is the hardest one to kind of explain, but I'm going to go ahead and try to do that here. Now A is a fixed, so you can actually have this triangle right here. That's going to be triangle 1, or you can have triangle 2, which would be this triangle. Now notice the side A here and the side A here, they're exactly the same lengths. The only one that changed was the length, okay? The other thing that changed is angle B and angle C changed. But A is the same as this A, B is the same as this B, obviously, and this angle A is the same, okay? So we could have up to 2 triangles in this case. So we can have 0 triangles, 1 triangle, either a right triangle and an oblique triangle, or 2, one acute and one obtuse. All right, let's go ahead and start. Here it says we're going to have no solutions. I'm going to go ahead and show you how to solve for these. You're always going to be given the angle A, or an angle and the opposite angle. So you're going to always be given a complete ratio. So when you're given a complete ratio, you need to find the angle of whatever side you're given. So in this case, we're given side B. We're going to look for angle B by using the law of sine. So I'm going to set up my ratio. Sine 28 degrees over 12 equal sine of B over 38. Bat and ball, so sine of B is equal to 38 sine of 28, all divided by 12. Okay, remember you need to separate the sine from the B, so we're going to do your inverse. So B is going to equal to inverse sine of this complete ratio. I'm going to go ahead and plug that into the calculator. Make sure you're on degree mode. We're going to do 38 sine 28 divided by 12. Okay, here I get 1.48 ... Okay, if you remember, sine cannot be a ratio greater than 1, so here we'll not be able to have a triangle. But let's go ahead and do second sine, second answer, and you can see that there's a domain error. So angle B does not exist. Here we have no triangle. Okay. Number 2, we're going to have one solution. Notice here I'm given angle C and I'm given little c. There's my complete ratio. So I'm going to find the angle of the side that I'm given. I'm given side B, so I'm going to solve for angle B. Okay, so let's start with our complete ratio. Sine of 68 degrees divided by 15 equals sine of B over 13. Bat and ball, sine of B is 13 sine of 68 divided by 15. B would equal the inverse sine of this complete ratio. Let's go ahead and plug that into the calculator. I'm going to have 13 sine 68 divided by 15, and I get 0.803 ... Let's go ahead and do the inverse of that. So second sine, second answer, and I get B is going to be approximately 53.5 degrees. Okay. Now that I have that angle, what I'm going to do is I'm going to assume that there might be a second one. So I'm going to go ahead and cut up my paper into two parts. Okay. So this is going to be what we call our B1. I'm going to put it here, B1. Okay. And over here, I'm going to say B1 is equal to 53.5 degrees. If we're given C and we're given B, we can solve for A. So A1 would be equal to 180 degrees minus the 53.5 degrees minus the 68 degrees. So A1 is going to equal to 58.5. Okay. So now we have all three angles and we have two of the sides. So let's go ahead and find the third side. Okay, and that would be little a. So I'm going to use the complete ratio again, and I'm going to say sine of 68 degrees over 15 equals sine of 58.5 degrees over little a. Use bat and ball. A is equal to 15 sine 58.5 degrees over sine of 68 degrees. Okay, and then I'm going to plug that into the calculator. 15 sine 58.5 divided by sine of 68. I get 13.8. Okay, so now I have angle B, A, and little a. Okay, if I'm looking for a second triangle, here's going to be your big clue. You're going to say B2 will always equal 180 degrees minus B1. So 180 degrees minus 53.5 degrees. Okay, let's plug that into the calculator, and you should get 126.5. Okay, now that you have B2, we're going to look for A2. A2 would be 180 degrees minus B2, which is 126.5, minus the 68 degrees, which is the part that's given up here. When I plug this into the calculator, you're going to see that what you get is a negative value. An angle can never be negative. So if you get a negative angle, this triangle does not exist. Okay, so we only have one solution. Number 5. Number 5 is two solutions. So I'm going to go ahead and set up my paper. It's important to be as organized as possible. Right? I'm given already one complete ratio, and I'm given an A. So I'm going to be first solving for angle A. Sine of 28 degrees over 10 is equal to sine, I'm going to call this A1, divided by 18. Okay. Use the batten ball. Sine of A1 is equal to 18 sine of 28 degrees divided by 10. Then I'm going to go ahead and take the inverse sine of whatever this ratio is. Let's go ahead and put that in the calculator. 18 sine 28 divided by 10. So I put it in the calculator and I get this ratio. Second sign, second answer, and I get A1 to be approximately 57.7 degrees. Okay, so this is where I'm going to go ahead and split up my paper into two parts. Okay, I'm going to start with A1 being over here. A1 is 57.7 degrees. I'm given B, so I'm looking for C. C1 would be 180 degrees minus the 57.7 minus the 28 degrees. Okay, use your calculator and you should get 94.3 degrees. This will be for C1. Okay, so now we have A, C, and B. We're given A, B, and we just need to find little c. So let's use our ratios again. Sine of 28 degrees over 10 is equal to sine of 94.3 degrees over little c. Okay. Batten ball, C is equal to 10 sine 94.3 divided by sine of 28. Okay. I'm going to go ahead and plug this into the calculator. 10 sine 94.3 divided by sine of 28. Okay. And C is going to be equal to approximately 21.2. All right. This is the completion of my first. Second triangle, I'm going to start with A2. A2 is going to be equal to 180 degrees minus 57.7. Okay, that comes out to 122.3 degrees. C2 would be 180 degrees minus the 122.3 minus the 28 that's given. So here C2 would equal to approximately 29.7 degrees. All right. Now we need little c. Use the ratio. Sine of 28 divided by 10 is equal to sine of 29.7 divided by little c. Batten ball, C is equal to 10 sine 29.7 divided by sine of 28. Plug it into the calculator and you'll see that C is going to be approximately 10.6. So for this case we have two solutions. Okay, number 6 is what we're going to do is find the area. Here we're given a side, angle, side. Okay, side, angle, side. Find the area of the triangle. You need to have one piece of information from each. So if you look here, the area, two sides, and the angle in between. Okay, so we're just going to fill this in. Area equals 1/2 10, 23 sine of 87 degrees. Okay, plug that into the calculator. and we will get approximately 114.8 feet squared. Number 7 says a helicopter on the path directly overhead of line AB, simultaneously observed from two locations, is separated by 200 feet. If the angle elevation from A is 39 degrees, so that means 39 degrees here, and the angle of elevation from B is 20 degrees, so we have 20 degrees here, what is the distance from each location to the helicopter, right? So what we need to do first is go ahead and find the missing angle. Okay, I'm going to call this C. C is equal to 180 degrees minus the 39 minus the 20. That equals to 121. Next thing I can see is that I have a complete ratio. I have sine of 121 divided by 200. So let's do that. Sine of 121 divided by 200. This will be little b, this will be little a, is equal to sine of 39 degrees over a. Okay? Use the bat and ball. A is equal to 200 sine of 39 degrees all over sine of 121. We get approximately 146.8. Since we're rounding to the nearest foot, I'm going to go ahead and say A is equal to 147 feet. Sine of 121 over 200 is equal to sine of 20 degrees divided by B. Okay. Bat and ball, B is equal to 200 sine of 20 divided by sine of 121. All I'm going to do is change out the 39 to be 20 degrees. Okay. And I get B is approximately 79.8 feet. Again, since we're rounding to the nearest foot, we would say B is equal to 80 feet. Okay. Number 8 says to estimate the height of a building, two measurements are taken. The first shows the angle of elevation to the top of the building to be 43 degrees. So I'm going to go ahead and draw a building here. And I'm going to do my first elevation from here to here to be 43 degrees. Okay. The second is taken 100 feet closer to the base. So I'm going to go forward 100 feet and take another angle. Elevation is going to be 78 degrees. So here we have 78 degrees. From these two measurements, estimate the height of the building. So what we're looking for here is H. Okay, first thing I would do in this particular case, and there's actually several ways that we can solve this problem. But what we're going to do is we're going to go ahead and try and find the angle here. We can do that first by finding the angle here. Okay. To find this angle, we're going to use 180 degrees. I'm going to go ahead and put it here. 180 degrees minus the 78 degrees. That's going to be 102. Now that I know this is 102 and I know that this is 43, I can easily calculate the angle right here. So 180 minus 102 minus the 43, that will get me this degree to be 35. And I'm going to write that down here. 180 minus 43 minus 102. Okay, that gets me this angle here. Now I have this corresponding ratio. Sine of 35 degrees divided by 100. Now what I'm going to do is go ahead and find the distance of this side here. I'm going to call this side X. Okay, so let me go ahead and do that ratio. I'm going to do sine 35 degrees over the opposite, which is 100, equal to sine of 43 degrees divided by x. I'm going to solve for x using the bat and ball. Okay, so x is equal to 100 sine 43 divided by sine of 35. Okay, plug that into the calculator and you get 118.9 feet. Okay, now that I know this side here, I can estimate the height of the triangle. Okay, so I'm going to use sine of 78 degrees over h is equal to sine of 90 degrees over 118.9 feet. Okay, bat and ball, h is equal to, hopefully you know that sine of 90 degrees is equal to 1. So I can just say 118.9 feet times sine of 78 degrees. And you get 116.3 feet. Okay, and then the problem says round to the nearest foot, so we're going to say the height is equal to 116 feet. Okay, and that's your answer. That concludes 6.2. Let me know if you have any questions.